In this lesson, we're going to take a look at reading position time graphs. Now, position time graphs actually show you quite a bit of information, but the thing that they definitely tell you is position at every point in time. So I can tell at 0 seconds this object was 1, and let's say this is measuring in meters, 1 meter in front of the reference point. I know it's in front of it because it's a positive 1 meter. At 1 second, 1 second later, this thing was 2 meters in front of the reference point. 2 seconds later, it was 3 meters. Okay? And then, so we can look at this at any given time. We can tell you the position of the object. Between 5 and 6 seconds, at this time, it was between 3 and 4 meters in front of the motion detector or the reference point. So it is actually telling me a position. It's telling me a distance and a direction from a reference point. Now, we can actually analyze this graph a little bit more detail. And the way we do that is we break it down into time intervals. And we pick things that make sense for time intervals. So where motion changes. From 0 to 3 seconds, I can see that this is a fairly straight constant line. Everything looks similar. So I'm going to use delta t for change in time, or my time interval. And the first one I'm going to pick is 0 to 3 seconds. That's this time interval here. Okay? Now let's think about what happened. I want to know where the object started. So its initial position. You'll see me write that as xi for starting or initial position. It started at 1 meter. I want to know where it ended. Well, the end of this interval is 3 seconds. So I go to 3 seconds and I find where it ends, and I see that that's 4 meters. So my final position is 4 meters. Now I want to know the displacement. Displacement, remember, is the distance from start to end, but there is an equation for that. Displacement, change in position, is always final position minus initial position. So that's 4 minus 1, which equals 3 meters. So the displacement from this thing for the first 3 seconds was 3 meters. And then if I want to know the direction that this thing moved, I can either say away or towards, and since it moved from 1 meters in front of the reference point to 4 meters, I can say that it moved away. Now, my next interval I'm going to pick is 0 to, or not 0, it's going to be 3 to 4 seconds. And from 3 to 4 seconds, my initial position, which is now the beginning of this time interval, is 4 meters. You'll notice that's the same as the ending of my other interval, right? It didn't jump up 10 meters. Okay? My ending position is also 4 meters. At 4 seconds, it's still at 4 meters. So 4 minus 4 tells me that it didn't move. And so for my direction, I'm going to put stop. It didn't have one. And then my last time interval I'm going to use here is from 4 seconds to 8 seconds, because that motion all looks the same. And my initial position is 4 meters. My final position is 2 meters. And that means my displacement is 2 minus 4, which equals negative 2 meters, which is towards the detector, or towards the reference point. And I want you to notice that that is a negative 2 on my displacement. That's okay. That negative is indicative of a direction. It tells me it's moving back towards where it came from, which is perfectly all right. Not only so, looking at this graph, I can see a couple things based on the steepness and the slope, and the steepness of the slope and the direction of the slope. So let's go back to this interval. I can see that this interval is steeper than the second interval, and this one has no slope at all. And let's look at that. This one's steeper. It covered 3 meters in 3 seconds. This one has no steepness. It's flat. It didn't go anywhere. And this one got steepness, but it's not as steep. It doesn't have as much slope as this one, and it only went negative 2 meters in 4 seconds. Okay, and that lets me know that this one is fast, this one is slow, and the interval in between is actually stop. Okay, so the steeper the graph, the faster it is. Steeper equals faster. It doesn't matter if it's going up or if it's going down, steeper is faster. But you'll notice that up correlates to away motion, so this is away, and this negative slope indicates that it's moving towards or getting closer to where it came from. So direction of slope indicates direction of motion. So, don't be afraid of position time graphs. They tell you where an object is and at any given point in time, but looking at the slope can also tell you if it's moving relatively fast or slow and also which direction it's moving.